Alright, the next tutorial is kinematics motion graphs. So on your kinematics motion graphs, we're going to start with question 1. You have to be able to recognize the different graphs versus time, distance versus time. So we know that if this is distance versus time, that this graph is showing us the velocity of whatever the object is. So if we have a car which travels with a constant non-zero acceleration, meaning that it is not at zero, it has acceleration, along a straight line, which graph best represents the relationship between the distance the car travels and the time of travel? So this means that velocity is going to increase because there is an acceleration that is constant. If acceleration is constant, that means it's going to be number 4 because it's not getting faster and faster. Number 1 would show an increase in acceleration as time went on. This one shows that velocity is constantly increased and there's no change, there's nothing getting faster or slower over time. So number 4 would be your answer. Question number 2 says determine the speed of the car at the end of the first 10 seconds. So we have your answer, your question, which says a car on a straight road starts from rest. So that means that our initial velocity is going to be 0 meters per second. And accelerates at 1 meter per second squared. So our acceleration is 1 meter per second squared. And it does this for a time of 10 seconds. Then the car continues to travel at a constant speed for an additional 20 seconds. So the total length of time is going to be additionally 20. So for question number 2, determine the speed of the car at the end of the first 10 seconds. So determine the speed of the car. You need to make sure that you know that the equation is acceleration equals the change in velocity over time. Which also means that acceleration in this case is 1 meter per second squared, which is equal to the change in velocity, which is what we are looking for, divided by the time, which was over the 10 seconds. So really we're just doing 10 times 1, so our velocity is 10 meters per second. Question number 3 says, on the grid at below, use a ruler. Let me go to that. Use a ruler or a straight edge to construct a graph of the car's speed at a function of time for the entire 30-second interval. So that means if we're going from the whole 30 seconds, the first step we go from is at a speed from 0 to 10 meters per second as we calculated above. So our graph should look like at 10 meters per second, when 10 seconds have passed, we are at this point. So you should have an increase there. Then it continued at that velocity for another 20 seconds. So we had 20 seconds and then at 30 seconds for the total, which means your graph should have a flat line across to show no change in the speed. Okay. Alright, so that's question number 3. Question number 4. Calculate the distance the car travels in the first 10 seconds. So that means if you look at your equation sheet that I'm going to I provided for you, these were the same equation sheets that they used last year on the LEOCT. So I'm assuming that they're going to use it this year again. There is a lot of stuff on here that you're not going to use, but the stuff that is on here, please make sure that you're looking at it. So, and a lot of it is just, it's all derived from the same 2 equations when we're talking about the kinematics. It's all derived from your velocity and your acceleration equation, and all they do is derive these different problems. And they've placed these problems on here, which can be very helpful. So for the first one, we have distance is what we're looking for. And so we do have the acceleration, velocity, and the time. So we're looking for each of these. So the best one to use when I'm looking at this and I'm trying to calculate the distance that is traveled is really going to be my distance, which is the delta x, which is representing the distance. I have my initial velocity, which I know is 0. I have my final velocity, which I know ends at 10 meters per second based on what my graph has shown and what I have calculated. I also know that the time that it occurred was a total of 10 seconds as well, because that's what the question is asking, only for the first 10 seconds. So I can figure out the distance based on this equation. There are other ways for you to do this. You can kind of go through the velocity and then change to the distance equation, sure. But if you go through this list and pick out the equation that fits with the variables you have, it's going to make your life a whole lot easier. So for question number 4, that's what we're going to use. We're going to use the distance equation, which equals half with my initial velocity plus my final velocity times my change in time. Okay? So my initial velocity I know is 0. And my final velocity I know is 10 meters per second. And my change in time is 10 seconds. So I really have half times 10 times 10, which means I'm going to have a total of 50 meters. And that's the total distance traveled in that 10 seconds. Okay, so make sure that you go through the reference sheet, make sure that you're looking at it, and understand what is being provided for you. Alright, question number 7, which is on the next page. Question 7 says, which of the graph best represents relationships between acceleration of an object falling freely near the surface of Earth and the time that it falls? So if an object is falling freely, acceleration does not change over time. Acceleration is constant for Earth's gravity. So if I'm looking at gravity for question number 7, gravity on Earth is always going to be 9.8 meters per second squared, which can be rounded up to 10 meters per second squared. And the reason that you can do this is because gravity is not constant. Depending on your elevation, it can be greater and it can be less than, so we usually just tend to round it up to 10 meters per second squared. Alright, the last 2, we're going to do question number 11. Question number 11 says, what is the acceleration of the car at time equals 5 seconds? So this is a velocity versus time graph. At time equals 5 seconds, I know that my velocity is 10 meters per second. So question number 11, I know that I'm looking for acceleration, which is change in velocity over time. So velocity is 10 meters per second over the total time, which was 5 seconds, and that's equal to an acceleration of 2 meters per second squared. So your answer should be number 2. Question number 12. What is the total distance traveled by the car during the 6-second interval? So if I'm looking at this, I can kind of take this 2 ways. I know that there's 2 paths. There's the increasing from 10 meters to 10 meters per second, and then the 4 to the 6. But really, because it doesn't change, you can just do the entire thing. You don't have to do it in 2 separate problems, but if you want to, you can. So I know that velocity, maximum velocity, goes from 0 to 10 meters per second. So my final velocity is 10 meters per second. And then I know that the total change in time that has occurred is 6 seconds. So in order to figure out the distance, I know that velocity equals distance divided by time, which is our average speed equation. So that means my velocity, which is given as 10 meters per second, times the total time taken, which is 6 seconds, is going to give me 60 meters. And so that should have been your question number 4. Alright, if you have any questions about any of these, please make sure that you ask during class.